Hi, this is Ben Welsh, here again in the LA Times newsroom. We're going to pick up where we left off in the last video after having filtered our pandas data frame. And in this one, I'm going to teach you another trick for working with your tables. It's called merging. It's where you take more than one table and you stick them together into one combined table so that you can have the two things connected. This is a really common thing in working with databases and complex information systems where there's a relationship between two different data files that is then allowed to connect by having common identifiers. Now in this case, why would we want to do that? Well, it can help us filter down that larger contributions file. So as you may remember, we have two main data frames that we're working with in this class. One, which we've called props, is a list of all the committees active in last November's election, November 2016, and the propositions they were connected to, those connections between propositions and committees in that list of 100 and however many committees. And then the other one, which we called contribs, was a list of tens of thousands of individual contributions that were reported as having been received by those committees. And now our goal is to filter both of those down to just those connected to an individual proposition, the marijuana legalization measure known as Proposition 64. So in the last class, I showed you how to use Panda's indexing method to filter down the proposition table to just those 11 committees active in that race. Now we could try a similar trick to filter down the contributions table, but instead I'm going to show you a different way to do it because it's going to be a handy thing that you're probably going to want to use again and again in Pandas, and is one of the really cool things about it that other libraries don't make quite as easy. And that's called a merge. So the merge allows us to take two tables and connect them together into one combined table, which is a really common thing to do in relational databases like this one. And if you've ever written SQL code in databases, this is very similar to a join, as it's called in that system. Now, to make this work, we have to have a common identifier between our two tables, or a field that match between individual records that allow us to link them together. Now, let's look again at our tables and see if we can find it. I have here right in front of me, at the bottom actually, the info statement from our prop table, which had been filtered, because it's just prop, not props, it's prop. This is the one we filtered down to be just those 11 committees connected to Prop 64. And we can see the many columns on this table. Now let's look again. I'm going to make a new cell beneath this, and I'm going to run info on our contribs table that we'd like to join. And if I hit play there, I can compare the columns in these two tables. And one thing that I immediately see is that there's one that is shared between the two called Cal Access Committee ID. Do you see that? Where there's a column of an absolutely identical name that's in both of these tables. And because I'm familiar with this database and I set up these files, and I'm familiar with the Cal Access system, I know for a fact that those two things should be identical and be considered a link between the two tables, which is sometimes called a foreign key in database jargon, but don't worry about that here. It's really just the common field that we want to join these two things together on. And then when you join two data frames or tables together, whether you're in SQL or Pandas or in any other data system, there's different types of ways to join them. And the default in almost every system is what's called an inner join. And so it's taking the table on one side and the table on the other, say props and contribs, and it's joining them together. And an inner join is a case where after they've come together, only those records, right, where the identifiers match are kept. And so that can result in there being fewer records in the join system than in the two when they were by themselves, because there might be identifiers in this table that are not in this table. Say this one's much smaller, and so then when you join them together, you end up with a smaller joined table of only those things that match. Now, because our prop table has already been filtered down to only those propositions that are connected to 64, and our contribs table, which is much, much longer, has all of the propositions and all of the committees, if we conduct an inner join using that smaller Prop 64 table, it will in effect do exactly what a filter would do, and what comes out the other side will be a join table with both of them linked, and the contribs will have been limited to just those whose Cal Access Committee IDs exist in the shorter Prop 64 table. All right. Now that was a little long-winded. Let me show you exactly what I mean. So before we began, my contribs table had 56,000 entries from many, many different committees in many, many different propositions. And we only had 11 different committees on this side. All right, and there's many, many more in this table. So let's try the merge, and then when we're done, let's compare how many records are here before and then after the join so that we can see the effect. All right, so now we're going to write some code. So get into your notebook, and let's go down to the bottom cell. You can add a new one if you need to with the plus button. And I'm going to show you how to do a merge. All right, now merge, just like read CSV or data frame or series or many other the built-in basic tools, is included inside the magic PD alias that we set for pandas. So a PD and then a dot, and again we can use tab to kind of look at all these many, many tools. Inside this list is one called merge, right? And so we're going to do pd.merge to access that merge method. And then we need to pass into it the input that it expects to conduct this join, this inner join that's going to do the filter we'd like. Okay? And I just happen to know, because I've used merge before, but we could go look at the merge documentation too for a reminder if we needed to. I just happen to know that the arguments it expects are the data frames, which is 2 is typically what you would do, but sometimes people do more. The 2 data frames that you'd like to join together. So the first data frame that I know I want to start with is that short list of Proposition 64 committees that I want to start with, and that was named prop. And so inside the 2 parentheses, the first thing I'm going to pass in as an input is the variable prop, which contains that list. Then, because in this case we're going to have more than one input, which I don't think we've done before, you then put a comma and a space, but you stay inside those parentheses as we add more and more options. Okay? And now the second thing we're going to give it is the other table. And that one, as you may recall, and you could just scroll up to take a look, we called contribs, right? Now if you gave yours different names earlier on in your notebook, you'll need to use those different names here too. Okay? So it's prop, comma, contribs. So those are the two data frames we want to join together. Now we need another comma, and we need to give it a third thing. We need to tell pandas what column we'd like it to use to merge the 2 together. And in some cases, the column might have a different name between the 2 different data frames, or you might want to use more than one column to conduct the join. But in this case, we have a very easy case in that the Cal Access Committee ID is what we want to use in both cases because the column has the exact same name on both tables. All right, and the way that you do that is we have to do something else we haven't done before, which is we have to pass in as an input what's called a keyword argument. So these 2 arguments that we've put in, prop and contribs, an argument is the technical term for inputs that you give a method. These 2 are traditional arguments in that they're variables or values that we just pass in directly in a certain order, right, separated by commas. But sometimes in Python, there are optional things that you can also pass in as arguments that are known as keyword arguments. And the reason they're called that is because you have to give a little prefix that matches the name or the keyword for that option that the method's function expects. And then you do an equal sign and then you put the value. So then I just happen to know, because I've read the documentation and I've done this before, that pd.merge accepts a keyword argument called on, right, followed by an equal, and then a quote, 2 quotes, and then in that quote, you should put the name of the column that you would like it to join the 2 tables together using. And so then this way you can be very specific about how you would like the 2 things to be joined, and pandas won't guess. Now if you didn't put anything in, it would guess, which I'm not a big fan of because I like to be very clear and to know exactly how things are being joined so that accidents don't happen. And accidents can happen with joins if you're not careful. You might end up with fewer records than you expect, or a bad join could lead to your data being malformed or messed up. And so it's very easy to do these merges in pandas, but you also need to be really careful that you don't screw things up in the process. And one way to do that is to be really explicit about the columns you'd like it to join. So we're going to do that using the on keyword argument, and then I'm going to write into it the name of this column, which I know is common between the 2. Cal Access, which again is the name of the state database, underscore committee underscore ID. So here we go. I'm just going to read it again from the start. pd.merge, open parenthesis, then our first data frame, prop, comma, space, our second data frame, contribs, comma, space, on, and there's no quotes around on because it's a keyword argument. It's not a string or value that we're defining. This is a built-in thing in Python for this method. On equals, quote, then the name of our column, cal access underscore committee underscore ID, close that quote to complete our input value, and then close the parenthesis to complete all the options that we're going to pass into merge. Okay? Now, I'm going to go ahead and hit the play button. And now you may get an error here because there's a lot of inputs and a lot of things happening, but again, it's probably just a small typo or something that's not connecting with your variables, and you should just read that error really carefully and figure out what it is and keep replaying your cell until you can make it work. It looks like I did okay, and I got a data frame out as my output, which is really good. And so before we start looking at this too closely, I'm going to go back to my cell and I'm going to revise it to save this data frame into a variable, just like we did above when we were filtering or reading in the CSV. And again, I'm going to do that by left-clicking here on the side and typing in the name of the variable that I'd like to store this as. And I'm just going to call it merged. All right, I'm going to do merged space equal space, which will take the result of this method and it will save it in this little shortcutted name we've created called merged. All right, and then if I go up to the top and if I hit play again, you can see that nothing had happened and nothing printed out, and that's good, which means that merged has been saved into this variable. Now we're going to return to the tricks we've used again and again throughout this class to inspect what's here in our data frame. I'm going to type merged dot, I bet you can guess, head, open parenthesis, close parenthesis. Play it. All right, this gives me a little peeked preview of our data frame, and I can see these are some of the columns and stuff we remember from our props table. But if I go to the bottom here and I scroll over to the right, you can see that we begin to see some of the data from our contribs table as well here on the right-hand side, right? And there's the amounts and the other things from those contributions. Now, if I go back and look carefully here, I can see that in the committee name table, which now there's two versions of, X and Y, because that column existed in both data frames before the merge. Both are kept on the other side, and a suffix is appended. But more importantly, I can see that when I review this, all of these columns now say yes on 64. And that's because I believe we've now, in the process of conducting the inner join of our merge, have filtered down the contribs table so that it only includes those contributions connected to Prop 64. We can verify that and find out how many it is by going down into the next cell and then typing our other friend, info. So we do merged.info, open parenthesis, close parenthesis. We run play, and we can see now that the list of contributions has been reduced to just 860. And so that's telling us that only 860 of those however many thousand contributions we saw before were connected to these 11 committees in the Prop 64 race. And if you see something very similar to this, it's possible the numbers are slightly different if I've updated the records with some amendments from the government source, but it should be something in this neck of the woods and maybe even exactly it. And so if that's what you see, you've done great. Congratulations, you've completed your first merge.